Hi, everybody, and welcome to Next Level Electrosurgical Testing. Today, we're going to be learning about electrosurgery testing, which is one of the most confusing types of testing as we hear from customers. So we're looking forward to share more of our knowledge with you to make that easier. Today's presenters are going to be myself, Michael Raich, product manager here at Fluke Biomedical. I've managed all of our product lines at one time or another over the last 6 years. And I'm happy to share some of that knowledge that I've amassed over that time with you all. I'm also joined by Justin Ross, and I'll let him introduce himself quickly.
Hello, I'm Justin Ross. I'm a channel partner, so I cover the northeastern United States for sales. I also work with our key accounts team and one of our trainers, so you've probably unfortunately seen me on a lot of our how-to videos. And before this, I was a 20-year CBET working in the field, and I'm happy today to bring to you some of the things I learned as a biomed, as well as some of the quick guides we've made to help make your job easier. So with that, Mr. Michael, it's off to you, sir.
Perfect. No, thanks for joining today, and we'll move right on into an overview of what we're going to cover. And what we're going to cover is actually a lot of ground. So we're going to start with an overview of why ESU testing is important, what electrosurgical testing is, what it does, what can go wrong. We'll also touch on how to test and the testing standards that dictate what to do and how often to test. And finally, we'll go into the top ESU testing tips that will conclude with a live demo showing how to put some of those into action. So with that, let's jump right in. And we'll start with the basics. Always a good place to start, but what do they do? All right, and the electrosurgical unit produces a high frequency electrical current that allows us to cut tissue and control bleeding through coagulation. So the current flows through the patient, back to the generator, through the reference in the generator. And we'll touch on that in the next slide. But current is delivered through cable electrodes that are activated by some kind of switch, either a hand switch or a foot switch. And the cable electrodes are typically single-use disposable, and the foot pedals are reusable. There are some cases where in developing regions, we'll still see some reusable electrodes, but for the most part, they are disposable. So the main functions are either to cut tissue or to coagulate and control bleeding. And we'll walk through some of the methods of operation and how that works. So there's usually two methods of operation here, either a monopolar or a bipolar mode of operation. And the big difference, as you can see on the slide here, is how the current flows and also how far it flows through the patient's anatomy, right? Either a large portion of the body or a small portion of the body. In monopolar, we have an active electrode that can control either cut and or coag. And this is again controlled through a hand or a foot switch. So the current, in order for it to flow, has to get back to its source. And the way that it does this in monopolar is through a dispersive pad. So some do this through a metal plate that the patient kind of gets pressed against. Others do it through an adhesive gel pad, which is much more common and much more safe. The other mode of operation is bipolar. And there are some manufacturers that still recommend that you attach that patient return pad anyways, even when using bipolar. But here the flow path is from the active side of the handpiece to the other side of the handpiece. So it's a smaller path for the current to flow. This is used for removing or resecting tissue or to provide closer coagulation at the site of a surgery. So think about endoscopic or laparoscopic surgeries, this is where the bipolar mode is going to be largely used. And there are also two makes and models of ESU where there's a vessel sealing mode. And I want to touch on that as well. This is where there's a clamp, and what they're trying to do here is they're trying to cut away a blood vessel, right? They want to cut it and permanently close off that blood vessel. And this is done through a couple things. We have pressure through the clamp, and we also have heat produced by the current flowing through it. And they do that over a period of time to close that blood vessel. One example that you might know on the market is Valley Labs Ligature. And Justin, anything to add on that?
No, it's, yes, I guess the answer is yes, not no. Yes, there's something to, with ligature, this is something new that we weren't always used to testing, and there's a lot of confusion, and I see a lot of technicians shying away from testing it. They didn't really have the setups before, but we're going to show you here later on in the video just how easy this is to hook up and test. So yeah, let's just keep moving on then, brother.
Sounds good. So there are also particular and specific waveform shapes when delivering ESU energy to the patient. And it's really important to understand what good looks like here. So when you're viewing the waveform while testing, you can understand any differences that would actually indicate that a passing numeric value would actually be failing because the waveform isn't what it should be. So these units that do fail just based on waveform, even though the numeric testing value is passing, they should be removed from patient use. And you really want to make sure that both of those pass. The waveform looks the way that it should, and the numeric value that you're testing for is passing as well. So
hey, I'll toss in on that one. And this is something I didn't used to see when I was in the field, but I have actually worked on a few issues in the last few years where this is called out in the service manual. And again, this might be something that a lot of hospitals in the United States aren't used to. I'll tell a little side story. I was just overseas recently, and over there, everybody gets a service manual as soon as they get a new device, but it's not something that happens here all the time. In this, you really might want to get your service manual. You might be missing some steps that it's calling for, and this is one of them. Actually looking at this waveform and making sure that it looks correct. And it's going to take a little bit of extra setup to do this. You're going to probably have to have an oscilloscope. Let me rephrase that. You will have to have an oscilloscope, but in how you're going to tie that oscilloscope in. With the Fluke solution, it's easy. It goes right to the back of the QES3 with your 10-to-1 attenuation cable, and you can then set up your oscilloscope, and you can actually look at these waveforms. The one I know for sure is an Olympus. Olympus calls for you to do this.
no, it's great. I mean, it just makes sure that you're passing, right? Because if we just blindly go by the numbers, you could be missing a waveform issue. So
Correct.
that's the main thing here. And to talk through some of these waveforms, there's cutting, right? So there's either a pure cut or a blended cut. So when you're looking at a pure cut, this is when you're looking for, a narrow, deep cut. And this you're gonna get that through high frequency and low voltage. A blended cut is a little bit of a wider cut. So you're going to be using a lower frequency and a higher voltage. So it doesn't change how the waveform looks. It just changes what you're seeing in terms of frequency and voltage. For coagulation, on the right side here, you see that there are two distinct energy delivery spaces, right? You have one pulse and another. This is a high voltage and a low frequency delivery. And in general, the settings here are typically lower than in cut mode. But if you look at these waveforms, like Justin said, to look at them, you need additional pieces of equipment. And we'll hit on that a little bit later, but it is that oscilloscope. So later in the tips and tricks section, we'll call that out again. But just remember, the point of this is it's not just a numerical test value, it's also how the waveform looks. And if you see any distortion there, it shouldn't be put back into clinical use. So we have a poll question here, and we're going to ask you guys to put the answers into the chat. But everyone wager a guess here, right? How many patients are burned annually from surgical fires? Is it 0 to 10, 500 to 100, or 500 plus? And
Just so
again, just
everybody
put
knows,
those in the chat, and we'll just see what numbers you guys start throwing out there.
and I got this wrong. When Mike found this stat, and I guessed when we were setting up for the presentation, I missed this one. Yep.
Yeah, no, it's an interesting stat, especially when you think about this coming from surgical fires. All right, getting some interesting numbers here in the chat. So I'll jump to the answer, and what we actually see is that there are 500 plus cases where people are burned through surgical fires in this, and this is just a stat for the United States. So if I jump to the next slide, you'll see that we have 550 to 650 patients each year that are burned just in the United States due to surgical fire. So globally, that number is going to be higher. And the takeaway here is really that, in spite of the most vigilant efforts by hospital-based biomedical engineers, our third-party service providers, even our medical device manufacturers and their field service teams, incidents and injuries occur all the time, every year. Burns still happen everywhere, every year. And burns due to surgical fire are the most severe, right? But they're also the least typical. There are surgical burns not associated with surgical fire, and they also have a high incidence of occurrence. And this is why we'll call it here, it's really important to test the contact quality monitor, right, CQM, that really looks at the dispersive pad, right, and how it is contacting the patient. This is one big area of burns. And it really helps us know when that pad is pulled away from the skin, which in turn increases the risk of patient burns. There are also
That's
burns. Oh, go ahead.
I'd like to tie in there. This is something I really didn't understand when I went through school. Like I assumed that this pad, once it's placed on a patient, like you can monitor it, you can see it. It wasn't until I actually got to go out and help out in some surgical cases that I really understood that this pad is put on in prep for the surgery, and it's typically in a location under the drapes that you can't see once the surgical procedure starts. So as a tech, if you haven't had a chance to go in and watch a surgical case, it's really helpful, especially for the young guys, to go in and actually see how your equipment that you work on is being utilized, to understand about this contact quality monitor pad and just where it's placed. And you think about, some surgeries aren't just, 10, 20, 30 minutes. You can have multiple hour surgeries. And ORs, as we all know, are dry environments, right? And cool. So the patient's skin can get dried out during that surgery, and that pad can start to peel. And when you lose that nice big surface, you get down to a small surface. That's another source for a burn. And honestly, that pad usually goes on your backside, and I don't really want to burn there unless I really need to have it. I just have it on the surgical site. So just things to consider, and it's another one of those areas where I've seen a lot of biomeds skip that procedure. They do a few output procedures, but they might skip that contact quality monitor. And for me, that's one of the most important parts to check, again, because I only want to be burnt where I'm supposed to be and not where I'm not supposed to be.
It also increases the healing time, or increases the number of places that need to heal. And that's the last thing a patient wants when they think they're coming in for a routine surgery. So the other people that get hurt here is the test operator, right? You, me, that can happen too. So we have to understand, we're dealing with high frequency test current. So understand those risks, right? Check your connections and cables. These are all ways that operators can get hurt. And we'll actually touch on that in a little more depth later in the presentation. And these are units that are plugged into a wall, right? They're run off electricity. So we have electrical microshock from mains power. That's a possibility as well. That's why we do electrical safety. And the other thing is it's not just us, it's not just the patients, it's the clinicians. So make sure that they understand these risks, because they have to protect themselves and their patients while they're using it. We're only one side of the equation. So that's just a list of what can go wrong.
I've seen a bunch of those go wrong too. After 20 years of being in the ORs, a lot of these issues can be on like an anesthesia machine cart or on an endo cart, or they're on their own cart and they're getting wheeled around a lot. So I found a lot of power cords on my ESUs over the time were always cut because they got ran over by another cart. And some of those carts are pretty heavy. So when you have those heavier carts, you really got to watch that they're not cutting through on your on your power cords. So just something to keep in mind is looking at those power cords as they're laying across the floor. Make sure you get a good visual inspection on those, because that is one I saw a lot of.
Perfect. So now let me know what can go wrong and why we should do testing. One of the big questions is, how do we do testing, right? Where do these requirements come from? The IEC standards apply first and foremost to the medical device manufacturer, right? And that's for the purpose of design and validation testing, or getting the medical device onto the market. But out of that testing and the clinical trials that they do come out some model specific specifications, right? And then we're also going to have model specific inspection procedures, and you're going to find those in the service manual. So the service manual is what you as a biomedical engineering, clinical engineering department get. And this is also what your independent service organizations or even the OEM field service teams are using. So you're going to follow the ESU manufacturer's model specific inspection and testing procedure. But you can also look to that global standard for guidance as well. Typically, they've taken a subset of the international standard and called out what's relevant there for you to test with that brand and model, and also any specific technologies that they have in their device that might need individual attention versus maybe some other brands and models. So it's not just a blanket kind of one approach fits all. Make sure you're looking at that service manual because it is brand and model specific. Just a brief walkthrough of these standards, right? So IEC 61289-2, right? That's for the safety of high frequency surgical equipment. IEC 60601-1 is for low frequency electrical safety because it is off of mains power. 60601-2-2 is similarly, right, for the high frequency surgical equipment. And then as we move from the manufacturer to the biomed, right, as we do routine preventive maintenance, you might see that they ask you to follow IEC 62353. One of the callouts there is IEC 60601 is really looked at more on the medical device OEM side, the manufacturer, and it covers design validation type testing. That has some currents that can be seen as destructive or destructive testing for an electrosurgical unit, and it might actually shorten the useful life. So we are seeing a movement to 62353 in these manuals, but you will see in emerging market countries where they haven't adopted 62353, where 60601 is still being used, and that's the only standard to follow. So just some regional differences for those that may not know as we kind of look at it from a global perspective. So now we understand what we have to test, right? How it works, what can go wrong, why we have to test. We want to give you some tips to actually go and do your testing. Do it faster, do it better, do it more, safely. And the first one is going back to that service manual, right? Always go back to the manufacturer's service manual, and those should be followed. That test procedure takes into consideration those requirements for minimum performance and safety from the international standards, as well as that particular design and any innovations that brand and model of ESU may have.
All right, I got to interject here. I got to interject here, man. So listen, so it's not just make sure you follow the service manual. Make sure you have the right version service manual. I've legitimately read probably 2,000 to 3,000 service manuals. Yeah, I know I'm a bit of a geek. It's what I do at night, I guess. But when you read the service manual, make sure you have the right version of it, because believe it or not, manufacturers are people too, and they've made mistakes in some of them, and they've made new revisions. So make sure you have the latest and most accurate version of the service manual. You'll be amazed that a lot of times these tests will change over time. So you may have to do less testing than what you did originally, or the figures are slightly different, or the setup's slightly different. So this is something that I like to tell people a lot, and I was a biomed a long time ago, and in the old school days, the first thing you do was literally read the service manual. So if I had a question, my supervisor said, well, did you read the manual? Well, yeah. Well, read it again. Well, and I learned a lot. And again, please make sure you go back to that service manual. If you already have pre-existing procedures, maybe you're running a CMMS system, or maybe you're running our Fluke OneQA workflow automation system, any of those things, when you're getting in there, see which revision you have, and make it a policy, or check the policy in the department to go back and check out and see if there's a new revision of that manual, because you'll be amazed. I can speak to some some other OEMs that they're on like revision N or M. So there's been a lot of changes over the years with some of these products. So yes, please have that service manual and make sure you have the latest version of it.
No, that's a great point because minor revisions are made over time. We don't want to miss those.
Nope.
Okay, so the next point I want to jump on was just inspection frequency, right? The service manual typically has that inspection frequency. So follow that. But if it's not there, if it's not available, you still have to determine a frequency of inspection. So it's not just having a procedure, it's how often are you going to execute that procedure. One method, if it's not in the service manual, is to take a risk-based method or a risk-based approach. Which is available in a publication which you can reach out to us for. But the University of Vermont Biomedical Engineering Department kind of took an approach that looks through electrosurgical units and takes that risk-based approach. So do look for that. It's also available in Advantage training if you wanted to watch that in digital form. And the other thing is, in general, right, most major electrosurgical device manufacturers recommend semi-annual, but we are starting to see more and more come out with annual requirements. So again, those could be changes that come through the service manual. So don't miss those, because Justin said it can actually result in you testing less. Second thing is around safety, right? We're dealing with high frequency current, and that's a little bit different than what comes out of the wall through mains power, a little bit different than electrical safety testing. So high frequency current flow behaves differently, right? And it poses additional risks to you, right? It's more dangerous than what's coming out of the wall. And this is to you specifically as the test operator. So look and be safe. Read this application note that we put together because it's meant to make you, the operator, safer. And do look out when you're doing output energy measurement from the ESU, especially when you're above 1 megahertz. Again, it's the frequency part that makes this a little bit different than typical electrical safety testing. So keep yourself safe, download it, share it with your team, make sure your whole team is safe. And then one other thing before I let you jump in, Justin, is test lead improvisation is
You stole it.
Even more dangerous. Oh, see, I stole your thunder. That's kind of even more dangerous here because you're dealing with high frequency current. And if you made something up, there can be some issues here. And you have an example there, Justin, that you want to
Do I have an example? It's like I might have told you the story about zapping myself one night in an OR. So, I'll tell the story of myself. Years ago, I was working very late night in an OR because I couldn't get in till like 6 or 7 o'clock, so it was late. And in the manual, I was working on an older model ESU, and in the manual, you actually had to grab a piece of wire and jumper between 2 points on the back of the ESU. And by doing so, I was like, okay, no problem. I grabbed a bit of a piece of jumper cable, i.e. bared wire, and I reached in between those 2 points, and I was like, this could be electrified. So I used pliers to hold on to it with insulation. And what I didn't realize is that my insulation, my pliers had wore through. And when I jumpered that, I got quite a shock. It made my whole arm go numb. And I was sitting on the floor of an OR by myself, really like 2 or 3 in the morning going, wow, what a way to die in an OR by myself at 2 in the morning. The end result was I ended up with this really deep tissue burn in my hand. And it was weird because it wasn't like the surface of my skin. It was way down in my fingertip. It was like a head of a needle or a ball of a needle stuck way down in there. It took quite a while for it to grow up. So I learned a very valuable lesson that night. And again, we used to do all kinds of improvised testing. We used to take the pencil tips and stick them into the front of the ESU analyzer. Like that. Yeah, don't do that. It's a really good way to buy another ESU analyzer because what's going to happen is you don't have a good positive connection and it's going to arc out. And once it arcs out, it could cause damage. That spark could jump inside the QES3 and cause component damage. It'll also arc out in that socket, so you'll start to get increased resistance and your measurements will start to read off. So you really don't want to do that. So when would I do something like you see in picture 1? The only time I would ever really do that is if I got called in for a patient incident and somebody suspected that it was the disposable pencil. But that doesn't happen very often, because by the time they call the biomed shop, somebody already cleaned up the OR and threw it away. And so the disposable under question is usually gone. But if I had to, if I absolutely positively had to, I'd do it much like you see in picture 1 there, where you put the pencil inside the alligator clip and make sure it's nice and secure and you don't have any exposed metal. We just got done talking about high frequency leakage and high frequency outputs. So if you add cables to the front of your ESU, you essentially just turned it into a radio, and you can actually transmit signal from the outside of the cable. So believe it or not, the test leads that come with our QAS3 are a very specific length. So if you add to those for any reason, you're going to transmit. Another thing that you don't want to do is you don't want to stack. Again, I was guilty of this back in the day. Send my ESU analyzer on top of my ESU, because there's not only so much space in the OR. Well, you don't really want to do that, again, because it's going to transmit from one device to the other device. And yet, there's one more. You don't want to have them sitting on the same stainless steel table like we see in picture 2. Again, stainless steel is a conductor, and you can transmit from one to the other. So you really do want to have your ESU and your analyzer on 2 different tables and separated. Make sure your cables aren't crossed. And then when it comes down to it, those improvised connections really don't need to do it. You'll notice that the QAS3 comes with a whole smattering of cables, like 17 of them. Don't freak out. We'll show you. You only need a few of them at a time. It's really easy to use, but we gave you such a wide variety because different ESUs have different requirements of how to hook them up. And what you might find is, well, hey, you might find that our cable doesn't exactly fit correctly. This is another case to go back to that service manual, and you might find that an OEM has a test rig that you need to buy, and it will plug into the front of the ESU and then connect to your analyzer. So it'll jumper things together. So again, this is where we start to tie it all together. That service manual is key. You really got to have the service manual and see what it calls for necessary test equipment. You really got to watch and avoid making these connections. They're not safe. You can get erroneous readings. You can get hurt. And trust me, it hurts. And hurts, by the way, if I didn't say that. And it can cause a lot of damage. So that service manual, minimize improvised connections, and you'll really be well on your way.
All right. And the last thing I'll add here is just be cautious around active electrodes, right? There's a lot of danger there. So don't touch it. Don't touch the return pad or the plate, right, while it's active in either cut or coag mode.
Don't lick it.
Turn it off, right, before adjusting or removing any connections. And watch out for anything that's flammable. I mean, these are just things that I think are really important to say, so you think about it, because assumptions can be dangerous, right? But look around, because I just want to make sure people are aware of what's going on, because this is, one of the more dangerous things for us as operators to test.
It really is, and it hurts.
I think you mentioned that.
Yeah.
All right. So enough of safety, but I did want to move on to testing, right? Just make sure you do all the tests from top to bottom, because you want to cover all the functionality that might be in that ESU. So we have RECM tests, right? Return electrode current monitors. I think it goes by a lot of other names too, like REM, ARM, CQM, right? This is the one you were referring to earlier, right, Justin?
Yes, sir. Yep, that's the one that you always want to test. So you only get burnt in one spot. Your power output tests for monopolar, bipolar, cut, coag, any of the features that your ESU has, make sure you check those out, as well as your vessel sealing. And the next one's one I want to highlight on. I'm going to keep running on this one so you don't steal your slide back. This cross coupling and the high frequency leakage tests. After the REM test, these ones I don't see tested a lot at all. Again, people don't understand it and they just kind of walk away from it. But it's so simplistic once you really read what you're trying to do with this test. And I'll just brief explanation with cross coupling. Say we're going to hook up like your monopolar output test, and we're going to hook up into monopolar 1. So what we're going to do is we're going to hook our connections into monopolar 1, like we're going to test it, but we're going to activate monopolar 2 at the highest setting, make sure no energy comes out of monopolar 1. And then we'll activate bipolar at the highest setting to make sure no energy comes out of monopolar 1. And we're going to work the way around the ESU. And then we'll move that over to monopolar 2 and test all the other ports. But when you read it in the manual, it reads kind of weird. So we'll show you some ways to help you out with that. But that's a really important test, because in that OR, they might have multiple tools laying on the surgical surface or on stands, and you really don't want to key up monopolar 1 and have monopolar 2 sitting over there with an instrument laying on top of a metal surface and have it arcing out. So that's a really important test to it. We talked about electrical safety, but high frequency leakage is this different form of leakage. You have your wall voltage or your wall leakage you have to check for in the chassis, but again, you can have the high frequency leakage. Again, very simple test to set up. The QAS3 makes that really easy to do. And I'll let you talk about argon, since you're the gas flow analyzer guru.
Well, I got one point I want to make before that one, which is this power distribution or output test.
I missed that one.
It's all good. I just want to make sure we touch on it, because what this does is it uses multiple loads to determine how well the impedance sensing circuits are working, right? Because you'll have current ramp up or ramp down as a result of that. So you'll need multiple loads to do that testing effectively, and the QAS3 does have those loads. So do make sure that you're testing that function. And the other one is inert gas flow and pressure, right? Specifically argon for the most case. But they have an option on some electrosurgical generators to create this inert gas envelope, right? Because using oxygen can cause charring of the tissue at the site of the surgery. And if you eliminate that oxygen, it prevents that charring and has a cleaner, more precise incision. And these wounds actually end up healing faster and they have less infection. So you're seeing those kind of work through. But it leads us right into the next poll question. So again, in the chat, if you could type these in. But what instrument would you use to test argon flow and argon pressure? Is it an electrosurgery analyzer, a gas flow analyzer, or do you just not know? Because again, this goes back to making sure that you are using everything you need to run your procedure tip to tail, and argon's going to be a part of that.
I got this one right. Well, I didn't get the first question right. I did get this one right, just so everybody knows.
Hey, 1 out of 2 ain't bad. All right, so seeing some answers coming in, but I think we're all kind of leaning in the same direction here, which is great. So it's a gas flow analyzer. And with that, I'll jump right to the next slide, which is, hey, let's make sure that we pair any additional equipment with your electrosurgical analyzer to do comprehensive testing. And that list of test equipment that we believe would be helpful is here on the screen. So electrical safety analyzers, right? We have high frequency leakage, but we also have low frequency electrical safety and applied part leakage. So keep an electrical safety analyzer close by to complete the electrical safety portion of your preventive maintenance procedure. The other thing Justin brought up earlier, a medical oscilloscope. These can be used to show the actual wave shape of a device under test. And this waveform can be just compared to the DUT's service manual and visualized by plugging the oscilloscope into the back of the QAS3. Then the last one was what we just had in the poll question, argon, right? You have to measure argon flow and argon pressure, and not all gas flow analyzers can measure that. Our VT can, so make sure that your analyzer can measure this, and then stretch that ROI, right? So think about your gas flow analyzer as not just being able to test your ventilator, not just being able to test your anesthesia machine, but now you can look and test your electrosurgical generators. Justin, didn't you have an interesting conversation with your wife over dinner one night?
About argon?
It might have started as an email from me.
About how many different things we could test with our gas flow analyzer? Yeah, I lost that one. Yeah, my wife was.
It went everywhere from compression devices to pneumatic surgical to.
Oh yeah,
Yeah.
She beat me. So the challenge was to figure how many devices we can test with our VT, our gas flow analyzers. And we had a pretty good list going, and I thought I was doing pretty well. And I sat down at the dinner table with my wife, who's a surgical technologist, and she definitely came up with like 3 or 4 more isoflators, SCDs, compressions. I was like, oh, yeah, I knew that. Yeah, right.
All right, we'll
No.
quickly go through a couple more here. But there is a special function on the QAS3 that can help save you time, and that's the autosave functionality. It's not a requirement for you to use, but it can save you time. And basically, testing with an electrosurgical analyzer can be unwieldy, right? But there's an internal foot switch to the QAS3, and this can allow you to automatically save the output energy, your HF, RF leakage currents, your power output, all of that. As long as it's properly connected, you can really save a lot of time. And Justin, you have a lot of first-hand experience with this, don't you?
I do, because when you go up and you set up for testing, you'll find out like the ValueLab FT10 has a service mode you can get in and run for your service mode, but not all ESUs have that option to go into the background, and a lot of times, when you get a brand new ESU, it has all the accessories, it goes up to the OR, but as we all know, it doesn't always come back to the shop with all the accessories, so you might not necessarily have a foot pedal. Well, now how am I going to test out all these features without this foot pedal? And this switch feature makes it so nice because you can activate the cut, you can activate the coag, you can do the cross cupping, you can do all these things without having to go and track down those accessories. And the other thing that's really nice about it, when you use that automatic feature, it holds the value on the screen of the QES3. Why this is important to know is because there's a duty cycle for the ESU and a duty cycle for the QAS3. QAS3's got a lot of fans. You're going to let the magic blue smoke out of the ESU before you let it out of the QAS3. So if you have to do a lot of testing, like some of these PMs can be kind of lengthy, you can build up a lot of heat in that ESU. Remember, they're only used for a few seconds at a time. So you want to try to minimize that cycle that you're running it to get a stabilized answer. But with this, you can hit it, it'll go, and it'll save the answer right there for you to read and write down. Because sometimes the ESU is going to read in amps or milliamps or wattage, and you have to kind of do a little bit of, wait a minute, oh yeah, it reads like this, now I have to translate it over. So it's a really nice way of holding it as well.
Yeah, so look into that. It's a really helpful feature. This
And
one
we got a really awesome guide to show you how to do it too. Super easy. Trust me.
That's true. Justin does know a little bit about it. So this slide might be a little bit pedantic, but it does come up all the time, right? Return the settings back to the way they were when you took the unit. You probably have been burned a couple times by this. Someone might have said, "What do you do to my ESU?" Or, "Hey, you broke it." But document the settings at the beginning of the test. Return them to those settings at the end. Just save yourself some time and some steps.
Yeah.
That seemed knowing. The other thing I want to touch on is use our application page. It's really a wealth of knowledge, has a lot of history on electrosurgical testing, some how-to videos. It's really just a great place to get some info. We want to give you a sense for some of these videos. So we'll show you the FT10 video here, which has been helpful to many.
We're here with the ValueLab Covidien FT10 and the Fluke Biomedical QAS3. And what we're going to do is we're going to go over some quick connects. If you're out in the field and you want to do some quick energy output testing and you might not have all the accessories for the FT10, maybe you're missing some foot pedals and things, how can you go about hooking this unit up? So this is where you show the true potential of the Fluke Biomedical QAS3. So the first wire I want to show you is right here. This is our CQM adapter cable. It's for a dual pad configuration for your REM or arm testing. And what we have the capability of doing is the FT10 is so smart it won't recognize single foil pad connectors. We do have a single foil pad. Here, I'll show it to you real quick. Here it is. And if you notice, if you connect it in, it sets off the REM alarm. It's not going to accept that. So we need to put a dual pad in. So we'll just disconnect that and we're going to put in the dual. Here it is. It's got the DIN pin on it, and it's got the 2 connect wires on the end of it. We're going to connect that into here. And in order to satisfy the requirements of the FT10, we've developed the man in the can. This is a resistor, so we're simply going to plug it in line with our dual cord REM pad, like such. There you go. And you can now see that the green REM light is on. That has satisfied the REM requirements of the FT10. So now we have 2 wires. The only thing we need to do is connect one of these. Either one's fine, but just because it's staying color coordinated, I used a black connector and plug it into the variable low of the QAS3. So what we'll do here is we're going to do a simple monopolar 2 output test. So we'll grab our red cable, our red variable high cable, connect this into the variable high of the QAS3, and we're going to put into the single port on the left of the FT10. There we go. And since we don't have a foot pedal, there's no way to activate this. We're going to simulate a foot pedal using the yellow and the blue cables from the QAS3. So this top quadrant right here, this section, this is to simulate the foot switches of the ESU. So we'll simply connect the yellow cable to the yellow and the blue cable to the blue. Then on the FT10, they're inverted. So where here the yellow's on the left, blue's on the right, we're going to put the blue on the left and the yellow on the right. Once this is completed, we have satisfied requirements of the FT10, saying that we've connected a handpiece and the lights are on. So now we need to have an activation cable. So you notice up here on the QAS3 there's one port missing, this common port. So we'll take the short black cable, we're going to connect it from the common of the QAS3 to the back side of the variable high port. There we go. So it's from the common port down to the back of the right cable on the QAS3. Now we're just going to pick some outputs here. We'll go ahead and we'll run this up to max settings. So 300 ohms cut and 120 coag. Now we're going to go to general output test on the QAS3. We're going to select cut and we're going to put it at 300 ohms. There we go. Okay, now once that's done, on our foot switch F2, above F2, where it says foot switch, you see the arrow, we're going to toggle up to cut, and we're going to push start single. Starting single will activate the cut. Here's your results. We had 300 watts, we now have 288 watts, and we can see these results, right? The results are saved as test 2. So there's how we test cut. Coag is just as simple. We'll push the F2 button, take it down to coag, and we're going to push start single again. Coag is activated. 120 watts, we read 113. This is just a quick function test. To get the actual readings, you should open up your service menu and read what your settings should be and what ohms resistances you should have, or loads we should have, and what milliamp outputs. But typically, I guess coag is done at 500 ohms, so we can turn up to 500 and try again here. Start single. 120, there we go, 115. So we're pretty close there, within 15% or so. And that's how you're going to do monopolar. So we're going to disconnect these cables here, and let's go ahead and let's talk about the bipolar output. Just to make it easier, we're going to get rid of all of these cables. So I'm just going to set them here on the floor. Now the problem with, here we go, take all these out. Now, for bipolar, we're going to use our red cable. We're going to go to the variable high and the left port of the bipolar. And we'll take our black cable and we'll go from variable low to the right port. There we go. Now our bipolar is activated, but we don't have the pedal here, so we can't activate this. So if we get back into the accessory kit, the QAS3, you'll find this cable right here. See, the end of it's a little bit different than the other cables. It's missing the banana pin. This we're going to put from the cut of the QAS3 down here, and in between these two ports, there's a small little hole, and that will plug into there, right like that. Now we need a common jumper here, so we're going to run this common jumper from the slit section to the back of the red port again, just like we did with the monopolar. And since we're plugged into cut, we're going to select cut with the foot switch. We're going to take this down to 100 ohms. Again, refer to your service manual to find out where you want that. Here we have 70 watts. Start single. 70 watts is activated. And here we have 67.7 watts. So there again, we have tested the monopolar output and the bipolar output of this ESU without using the foot pedals. Again, a nice, quick, easy way to go out. You get a call up in the OR and they want you to check it out real quick. Nice, quick, easy way to hook it up without having to find all your foot pedals. Well, that leaves the ligature. So the ligature, unfortunately, you're going to have to remember how to get in the service manual. But we'll show you how to do this here real quick while we're here. Disconnect all these cables. The ligature cables look a little different again. We're gonna hold up a black. Here's your standard black variable load cable, and here's your ligature cable. See how the ends are different? This one you can butt them into. But the ligature, there's no port in the back. So we're gonna take the variable low over here to the far right port of the ligature, and we'll take the red ligature cable to the variable high, and over here to the left port of the ligature. There we go. All right, well now I see the REM pad's not satisfied. So what we're gonna do is we're gonna go into service mode, and then we're gonna go into service, and we're gonna enter the access code. You can find that in the service manual. 423213. Again, please reference your service manual to make sure everything's safe and you're within the specifications. We're gonna hit OK. We're going to go to RF output tests. Once we're here, we're gonna select BPR coag, effect 6, put 50 ohms here, start continuous on the QAS3, and activate. And there you can see you have 1,832 milliamps, and over here you have 1,866.6 milliamps. There you go, that's how to test the ligature.
All right, so yeah, that's an example of just a great video that many customers have told us they reference on a regular basis. So thank you for pulling that together, Justin. No problem. Another item that I had circled on that application page on the previous slide was the ESU Connections Quick Guide. Customers have told us that the connections are confusing, but they really don't have to be. I'll point you towards this as a reference document. It's a multi-slide PowerPoint presentation to see how to make many general connections and even some specific connections for certain brands and models. We've pulled this together to help you. So make sure you reference it and you share it, because it can really be a huge help to you and your team.
Honestly, I teach QAS3 over 4 or 5 times a week, every week. It's just the very first thing. If I'm going someplace, I'll print these off and hand them out. If you can print it off in color, print it off in color. Keep it with your cables. It's really nice, and it really does cover most of the common issues.
All right, and then the last one before we hop over to the live demo. Think about it as a workflow, everything that goes into this. You have to open your work order, find a procedure, find your test tool, find your accessories, run the test, remember how to connect your accessories, document those results, get them back into your CMMS or your EAM system, and then maybe defend them in an audit. So think about that as an entire process and how you can streamline it. And OneQA is one option that you can use to do that. OneQA can actually help automate some of your testing. And you might be thinking, well, hey, QAS3 isn't automatable at this point. That's fine. VT650 900A testing is, ESA testing is. Just automating that can save you some time. But think about the procedure, right?
Hold on.
Oh, go ahead.
Even though QAS3 is not automatable, what I'm about to show you is just how easy, though, OneQA can make your testing. You just mentioned all these things about that manual and everything. What if we just get away from how the the old hard way of going and collecting all these things? Instead, let's just put it at our fingertips. That's exactly what OneQA is. So even though I can't automate the QAS3, I'm going to show you here in a second just how easy we can make this testing for you using this OneQA workflow automation software.
And that's it. Build a whole procedure that leverages all of those different tests, right? The QAES3 portion, you might have to put in your results manually, but they're locked down. They show you where to make those connections, right? What good looks like, locks down the steps so nothing's skipped, nothing's missed, nothing's illegible. And it gets that information to everybody in your facility without having to look up manuals or remember how to do X, Y, or Z. Generate reports automatically, right? Even if you type the results in manually, you still output a report that has everything in it for every tech in the facility. So avoid some really expensive rework that way. And the other thought, one last thing before I'll hand it over to Justin, is if we have the integration with your CMMS system, you can open and close work orders and make the transfer of data seamless, right? So you don't have to send anything over email or USB stick or scanning pen and paper. Skip all that. So where seamless integration is available, this can save you a lot of time. And one thing is hearing it, right? I can talk to you guys for minutes on this, hours even, but I want to toss it over to Justin to show you how it looks in real time. So Justin, take it away.
Okay, so here we are. We're in OneQA. So now the first question might be is how did I get here? Well, that is easy enough to do. If we got an integration with your CMMS, I simply go into the work order in your CMMS system, go to the procedure, I click a button, and essentially it opens OneQA and brings me right here to the procedure. So without even reading very much, you can see simply by looking here on my screen that I'm going to be servicing a Valley Lab Covidian FT10. And right here, it's for software versions 4.0 or higher, and it's 2.0 version. So I know everything I need to know about this before I start. Now, if I had connected my ESU or my safety analyzer, my gas flow analyzer, you'd see them populate up here at the very top prior to starting. So prior to starting, they'd be here, and you'd also see the make, model, and serial number installed right here in the test device. This is the asset information. Now, here's where it starts to get fun. Right now, I'm using a 60601-1 version of the safety test. If I needed to, I could go to my edit button, and I could change this to NFPA 99, because that's what we usually follow here in the US. And when I do it, it automatically changes all of my test standards. So that's really nice. Now I'll get into my actual inspection. And you can see here, I took all the steps right out of the manual and put them in here. So typically I'm running off of a Surface Pro. And what I do is I just go right down to Surface Pro with my touchscreen and I'll touch the pass or fail results. So you don't even have to say fail and pass. It can actually take the verbiage right out. So it says rear panel inspection. And the correct answer is the rear panel is free of damage. We can literally build this any way that you want it to do. Now here's where it gets really awesome. So let's get into the output tests. So here we go. We're going to do testing coag monopolar 1. Well, here's the diagram out of the manual, and here's all the instructions out of the manual. And I took a picture of how to set this up, saved it to my PC, and simply attached it to my procedure. So now every time I need to do this step, I don't have to think about it. I don't have to read this and try to determine what these are. All I have to do is set my cables up just like this. Here's my adapter. Here's my red cable. Here's my black return, and I'm moving on. You get to the next step. Oh, we're doing monopolar 2. Simple enough. Change the cable, put it over here. And you keep going right through the procedure. And this is where it gets so great. I don't have to worry about my intolerance. I simply just have to type in my result here. And if it's in between these two numbers, I'll get a passing green dot and I move on. If it's outside of that tolerance, I get a red circle and it says, stop, I got to fix something. So even here, like use the same setup as above. So this is more the same test. So I know if I'm following this picture, I can continue to do all these steps and right down through the procedure. And like I said, this is where it's really nice for me because all the things that I need to do my testing and my inspection are all right here at my fingertips. When I'm done with this and I hit save at the very end, it takes all this data, puts it into a PDF, and automatically dumps it back into my work order. The other thing that's great about that is I can set it up so all these pictures and all this extra stuff doesn't come, just the results. Only my results will transfer over. So This is just a quick glimpse of how OneQA is and how potential or the amazing potential of it. If you'd like to have more information about it, feel free to reach out to our team. We're happy to demo it for you and really show you just how powerful OneQA is and just how much better it can make doing your job. Makes it streamline it faster. And now we can get back to doing the things you really want to do instead of running a million tests. So with that, I'm going to go ahead and flip over and see if we have any questions. I know we're pushing for some time here. So if there's any questions, please feel free to add them to chat and we'll get right to those.
It looks like, Mike and Justin, we have quite a few questions that came in, and I know we're very close to time, so I'm going to filter out to see which ones that we can answer within the next couple of minutes.
Yeah, let's see if we can get a couple out of the way.
Okay, so the first question is, the connection in high frequency leakage test in bipolar is very complex. Lots of cable connections. Is there a way of making it more efficient or simpler?
Yeah. Well, bipolar testing, right, has two electrodes. So there's a hot and a return. And what you're doing is you're really measuring the leakage current from each of those, one at a time, and its leakage back to ground. The connections there aren't really that complex, though. You're looking at 2, maybe 3 connections maximum. Those videos, like the one Justin just showed, they're really helpful, and they're available in the video library. They'll show you the exact connections for certain brands and models, and those really help take away a lot of the confusion. Another place to look to make it a bit simpler is at Advantage Training. There's a lot of good information over there. It goes over the basics and even more. So those are the 2 resources that I'd point you towards to kind of look and see what those connections are for the brand and model that you're testing.
Okay, thanks, Mike. One more question. Is the REM connection in common for all ESU devices, or is there a need to change by manufacturer?
Okay, yeah, so REM testing, I just want to hit on this again. REM is the same as CQM, is the same as ARM. There's lots of different names, but this is monitoring the return plate, right, to make sure that there's a good connection with the patient. When that plate separates itself from the patient, the surface area of that return current reduces because less is in contact with the patient, and it creates a higher heat over a smaller area, and that's what causes burns. So we need that plate to have as much contact as possible to spread that current and heat out. Those units with monopolar modes will either have a plate or an adhesive pad. There are also tests in a bipolar test that will require the use of a pad or a plate as well. So do check your service manual. But again, yeah, these units that do need a CQM test, they might be slightly different with every brand and model. So I would point you back to the service manual to see if you have to do that.
Okay, wonderful. Mike, do you have time for one more question?
Yeah, let's do another one.
Okay, all right. Does twisting the cables whenever connecting the QA-ES3 to ESU affects the test results?
So if I'm understanding the question correctly, right, well, one way to interpret it is the cable itself. So if you're moving the cable, it would only affect the reading if you have a loose connection or a broken cable. And I hope that's not the case, right? If you're talking about potentially coiling the wires, where the wires end up crossing each other, this can absolutely have an effect on your readings. So these cables, Justin talked about them being a certain length. They're antennas. So shortening or lengthening that antenna through coiling or crossing can have a huge effect on your readings. So don't let that happen. Make sure your cables stay as separated as possible. And again, make sure that your cables are in good working order and that you don't have any loose connections.
Okay, wonderful. Thanks, Mike and Justin. We're actually a little bit over time. I do want to say thanks to both of you. Greatly appreciate your time this afternoon, and also to the audience. We appreciate your time, you spending time with us today and engaging in some of our questions. But I just do want to remind you that feel free to visit flukebiomedical.com for the additional resources that were mentioned throughout this presentation. This will conclude today's webinar, and we look forward to you joining us in our future webinar sessions. Have a great afternoon.
Thanks, everybody.